Hey guys, today we are going to learn how to match up equations to tables and graphs. Now, I think the hardest road we've already walked through. If you still need more help with it, don't worry, you have more time to practice it. And that is creating an equation from a word problem. But once you have an equation, matching it up to a graph or a table is fairly easy as long as you understand the different parts of the equation. So that's what I hope to teach you today. And so let's move forward with the lesson. So it says, how would you match a table to an equation? Well, one thing to note, if you haven't noticed already, that this equation has an x and a y. That x and y is just like an ordered pair. As x changes, it affects the y, and the y changes. So when I look at an equation, if I can remember that the x and the y are simply ordered pairs, it's easier to match up to tables and to graphs. Now, I know you know that graphs are when you create a dot, a point, or a line on a graph, it's by use of ordered pairs. But a table too, they're ordered pairs. So look at this first table right here. I mean, I didn't know if you realized it, but these are just three ordered pairs. And we can substitute the ordered pairs, the x and the y, into the equation and see if all of them work. And if all of them work, we know that that equation matches with that table. So let's go ahead and try it. This is all about substitution. So if x is 2, then that would be 4 times 2 minus 1. They're saying, would y be 7? Well, 4 times 2 is 8. 8 minus 1, does 8 minus 1 equal 7? Yes, it does. Now, that's not enough information for me to determine whether this table is correct. So let's try a second ordered pair. So this one says if x is 4, so that would be 4 times 4 minus 1, would y be 11? Well, 4 times 4 is 16. 16 minus 1 is not 9. So this is probably not the table that matches. Let's try the other one. If y is 3, again, let's just go off. This is the original equation. If the y is a 3 and the x is a 1, does this equation match? Well, is 3 equal to 4 minus 1? Yes, it is. 4 minus 1 is 3. So let's substitute one more time. So let's go to the 2 and the 7. So if y is 7 and x is 2, is 4 times 2 minus 1 equal to 7? Well, 4 times 2 is 8. Is 8 minus 1 equal to 7? Yep, it is. So that's going to be our answer choice. Now, normally I would ask you to check 3 times, 3 different ordered pairs, but since we already know that the other choice is not the correct choice, we're going to be happy testing it out twice. But I assure you, if you did it all 3 times, it would work. Let's look at the next one. This one is ordered pairs off of a graph. Now, this is where it's super important to be able to name an ordered pair in order to be successful at this next part. So I have an ordered pair, one for each graph. Let's see if both of them or none of them work out. So let's see, this is my x and this is my y. So if y is 3 and x is 0, would this work? Well, 2 times 0 minus 3 is a negative 3. So this did not work. This is an x as in not x the variable, but x it didn't work. Let me just go ahead and cross it out. Maybe that works a little bit better. Okay, let's try the other one. Again, we have y equals 2x minus 3. Again, this is all about substitution, so I hope you're okay with knowing how to do that. So I'm going to put, if this is the x and this is the y, I'm going to put the x right here. And I'm going to see if it's going to work. 2 times 0 is 0. 0 minus 3, well, it is a -3, so this one works. So I'm good with this one. Now, normally I could check 2 or 3 ordered pairs, but since the first one did not work, I know that this one's going to work. I go ahead and check it at least one time because sometimes I mess up on my calculations on the first one. So it's always good to double check yourself. Let's look at the next one. Again, remember, this is matching a table to a graph. Remember, these are ordered pairs. And it's really easy to plot these ordered pairs on a graph. So let's do so and see if they all end up on the line. If they all end up on the line, then we know that the graphed line matches the table. So 0, 2. 0, 2 is right here. So already we know that this one's not working out. Let's try this one. -2, 0. -2, 1, 2, 0 is right here. So that one checked out. -1, -1, -1. Look, that one checked out. And then 1, -3, 1, 2, 3 is right here. That one checked out. So that worked out great. So that's how we matched. So this is my correct answer. How would you match an equation to a table? Again, it's remembering that these are ordered pairs. Each one of these is an ordered pair. And that the x and the y in these equations represent ordered pairs. So I'm going to go ahead and substitute the 2 and the 4 in and see if it works into the first equation. So they're saying y is 4 and the x is 2. Is 2 times 2, which is 4, plus 4, does that equal 4? Nope, it does not. So this is not the correct answer. Okay, let's try the next one. Because this one here, let me go ahead and finish it. 4 equals 8, that's not true. The next one, again, I'm going to use the same table. I'm going to see if it matches the equation. If y is 4, and x is 2, is this a true statement? Well, let's see. 3 times 2 is 6 minus 2. 6 minus 2 is 4. So that one worked. And again, I could try the second and the third. And normally I recommend you to test something out 3 times. But if you've already figured out that the other one is not true, you really only need to test it 1 time just to make sure your math on the first one was correct. I hope that was helpful. Good luck. I think you're going to have a good time with this assignment. I'll see you later. Bye-bye.